In our first test type question that we did, they gave us a diagram and we had to interpret it and then answer the questions on it. Now, this is also a typical question where they don't give you a visual or the diagram, but they ask you certain questions. So you can obviously go make your own visual. That is always a great idea, but sometimes we don't need to. So let's see how this one goes. It says that we've got coordinate J and K. There's nothing missing in J or in K, and then we've got coordinate L, and there we've got something missing. All right, let's see. Those three are points on the Cartesian plane. We need to calculate for y in each of the following cases. So we've got three different cases. For the first case, it says, so we need to find y if L is the midpoint of JK. So we've got a line segment, J and K, like that. So we've got JK, and they're saying that point L is exactly in the middle. Okay, we can do that because we've got all that information. We've got coordinate J, we've got coordinate K, and we need to find the midpoint. So for A, is the midpoint of J and K. So if I add my two x values, that would give me -4 plus 8, and we divide that by 2. And then we've got -3, and we're going to plus 4, and we're going to divide that by 2, and that would give us the midpoint. So let's simplify that. If we simplify that, it would give us 4. -4 plus 8 is 4, divided by 2 is 2. And then -3 plus 4 is +1, so that will be a half. And there is midpoint L of line JK. So therefore, let's just answer the question. Therefore, what is y in that case? In this case, y is equal to a half, because there is the y coordinate of point L. Okay, so that's case 1. Let's see case 2. We need to find the y value if the gradient of KL is a third. Okay, well, we can definitely work with that. We can find the gradient of KL. Well, normally to find the gradient of KL, we would take the change in y's for K and L. So in this case, it would be y take away 4. 2 take away 8. So there's my change in y over my change in x. But then, in this case, they gave us what that gradient is equal to. So that gradient is equal to a third. So we know that a third is equal to that. What is 2? That's -6. Okay, perfect. So not just one way to simplify that. I think what I'm going to do, you can do something else just as long as it's mathematically sound. I'm going to multiply the right-hand side by -6. The reason why I'm doing that is because then those two cancel out. But then as long as I also multiply the left-hand side by a -6. So let's see what we're left with. On the right, there's going to be y minus 4 left. And then on the left, so I'm just going to show that working out over here for fractions, because most students, when they see fractions, it's as if they've never seen it before. Anyway, but you can just use your calculator for that as well. So I've got a third that's being multiplied by that. I'm just going to put that over 1. And when we multiply our fractions, it will give us that, and that will give us -2. Okay, so that's what we're left with. And then finally, to get y, I'm going to plus 4 on both sides, which will give me 2. So in the second case, where the gradient of KL is a third, that would mean that your y value for this L coordinate must be 2. So for the third case, we need to calculate the y value if we were given that KL has a length of the square root of 40. Okay, I'm going to do it over here. So distance formula for KL. So the distance for KL would be equal to, how would we normally find the distance for KL? We would plug it into our distance formula, and that would mean 8 minus 2, and then 4 minus y. So there is the missing y that we are looking for, but luckily we have the distance of KL that we can plug in over there, which is the square root of 40. All right, so now we've just got one missing thing that we need to find. Let's substitute there. We've got 8, take away 2, so that's 6, and if we square that, that is 36. And let's just go FOIL this out correctly. If we FOIL that out correctly, it will give us y squared, take away 8y, and then plus 16. Okay, so far so good. I think we are ready to get rid of the square roots. So with my equation, I'm going to square this side, and I'm going to square that side. Then I'm left with 40. And over here, I'm just going to put my like terms together and just change the order a little bit. Y squared minus 8y. And then I've got 36 plus 16. What is that? Is it 52? Can you see that we're dealing with a quadratic equation? So I'm going to take everything to the one side, and we are going to factorize that trinomial. Y squared minus 8y. And if I subtract 40 on both sides, I'm going to land up with a 12 there. I'm just going to scroll down. Okay, so whether you do this with your calculator or without your calculator, again, if you're struggling with that, refer back to the video on factorizing trinomials. If I look at the factors for 12, that would be 6 and 2, and it will have to be, I've got negative 6, and I take 2 more away, which will get me back to negative 8. Yes, there we go. All right. And then that means that therefore either y minus 2 is equal to 0 or y minus 6 is equal to 0. So y is equal to 2 or y is equal to 6. So there are our two solutions for that case. Let's just see if both of those answers will actually work. So let's just draw it roughly. I just want to show you something there. So if k, let's say, is by 8 and 4, let's say k is somewhere there. And we've got that L is by 2 and y. So 2 and y, so somewhere there. So x is 2 there, and then we don't know what the y would be. So L could be a point on that line. So we found that y value for coordinate L to now be either 2 or 6. So if it is 2, my y value will be 2. So then it would be somewhere over there. Or it can be where my y is equal to 6. So somewhere over there. Now, they both can work, because if you think about it, our distance from there to there can most definitely be equal to 40. But the distance from there to there can also be 40. I know it doesn't look it right now, but I mean, I was just plotting. It's not on scale. But that's why in this case, both those solutions will work. It's perfectly fine.